So taking a look at the adaptive milling operation here, you can see we need to use a quite dense step over to achieve an adequate milling in this hardened material. And let's take a quick look at the material removal that we are doing here. As you can see, it's this special adaptive milling tool path, and like I said, we are achieving a consistent chip thickness here throughout the complete tool path, so there will be no full cuts or the tool won't be over embedded, and therefore we can use way higher feeds and speeds than in traditional milling, and we are using the complete flute length here. And we can look at this on the real machine. Here are some parameters that we are using so that you're aware which parameters we use to actually rough this part. NXCam adaptive milling is very effective in breakthrough regions where, as you can see now here in a second, it will break through from one region to another. We are doing this very effective while saving tool life at the same time. This is what adaptive milling is known for. Besides the high feeds and speeds and therefore these high chip removal rates, we are also really taking care of decreasing the tool wear and therefore increasing the tool life.